So it's quite simple. We have a .java file, that is the source code. This .java file we have submitted to compiler, that is our Java compiler, and the Java compiler will generate what's up this test.class file. Now this test.class file, this is the byte code we want to load into the JVM memory. If you remember, I told you earlier the main purpose of JVM is what, sir? In my earlier classes, I told you very clear message I had given you. The main purpose of JVM, the main purpose of JVM, the main purpose of JVM to load and execute, to load and execute. Remember this point: to load and execute, to load and execute the dot class file, the dot class file. Okay, sir, to load and execute the dot class file. Remember this point very well. To load and execute the dot class file. So here we have a dot class, sir. Look at here we have a dot class. Now I want to load and execute this dot class file. I want to load and execute in this dot class file. Now to load and execute this dot class file, what we require, sir? Sir, first of all, to load this dot class file, we need what? We need a class loader subsystem. Now, class loader subsystem is a component of JVM. Class loader subsystem is a component of JVM responsible to load the dot class file into JVM memory. Okay, once again, sir, class loader subsystem is a component of JVM, is a component of JVM, is a part of JVM responsible to load the dot class file into JVM memory. Okay, sir, I want to load the dot class file into JVM memory. Sir, what we need to do, sir? Sir, we need to take the support of class loader subsystem. Sir, what this class loader subsystem will do, sir? So this class loader subsystem responsibility to load, not to execute, load the dot class file into JVM memory. Yes, sir. This is the responsibility of, sir, class loader subsystem. So for this topic, actually, I have created a PPT also. Okay, but let me first give you the diagram how the class loader subsystem loading this dot class file into JVM memory. Internally, whenever you load this dot class file into JVM memory, internally, what are the things the class loader system is performing, or after loading, what happens internally? Okay, what happens internally. So first you take the screenshot of this one. The main purpose of JVM to load and execute the dot class file. Just wait, let me write one more statement, sir. The class loader subsystem. Please wait. The class loader subsystem is a component of JVM. Component of JVM, and the responsibility of class loader subsystem, class loader subsystem to load the dot class file into JVM memory. JVM memory, to load the dot class file into JVM memory. Yes, this is one of the most important parts, sir. Okay, to load the JVM memory. Please take the screenshot now. So this dot class file actually we need to load into what's a JVM memory. Please take the screenshot. So I hope you have taken this screenshot. Now let me draw the diagram. Okay, let me draw the diagram of what? Class loader subsystem. Okay, before going to the actual part, look at actually what is the our agenda here. What is the complete diagram? Actually, this total cinema is divided into three sections, sir. Listen carefully. The total cinema is divided into three sections. Okay, and it is a big topic. So the first part, the first three topics, sir. Three topic we need to cover. The first part we need to cover what, sir? First part we need to cover what, sir? Class loader subsystem. Class loader subsystem. This is the first part. Now, what is the second part? The second part is what, sir? When this class is loaded successfully, when this class is loaded successfully into JVM memory, then JVM divides the component of dot class file, or JVM divides the part of the dot class file into different memory. You remember heap memory, stack memory. Okay, all the objects are created at heap memory. All the methods are executed as a part of stack memory. Okay, so like that we have five memory areas, sir. We have five memory areas: method area, heap area, stack area, PC register, native method stack. Okay, these areas, these memory areas are known as what, sir? Runtime data areas. Runtime data areas. These memory areas are known as what, sir? Runtime data areas. Method area, heap area, stack area, PC register, and native method stack. This is the second part. Okay, to divide the part of the class into different memory area. Let's say in a class I have a method, so this method will be executed as a part of stack memory. Sir, I have an object, so this object will be created as a part of heap memory. Like that we have what? Method area for holding the class data, we have PC registers, we have native method stack. Each and every memory has some specific task. Specific task we will learn in detail, don't worry. The third thing is what, sir? Execution engine. Execution engine, this is responsible to execute our actual Java program. This execution engine is responsible to execute what, sir? Actual Java program. Okay, from this execution engine we are getting the output. From this execution engine we are getting the output. Okay, so class loader subsystem, then runtime data areas, and then what's a execution engine. So if you look at this presentation part, sir, if you go to the presentation part, yes, class loader, yes, just look at, have a view, then we will create a diagram. Okay, okay, so here, sir, this is our topic: class loader subsystem with JVM architecture. Class loader subsystem with JVM architecture. Now, if you just look at this one, you will take the screenshot as well. Just look at, sir, in order to execute a successful Java program, we need three parties, sir. Sir, what is, sir? In order to execute a successful Java program, we need three parties. Of course, we need three parties. The first party is what, sir? User. The first party is what, sir? User. User is responsible to write the code. User is responsible to write the code. What is the second party, sir? Second party is Java compiler. Java compiler is responsible to compile our code. So third party, sir, of course, JVM. JVM is responsible to execute our Java program. Okay, so three parties we have, sir. What are those? First is user, second one is compiler, third one is what, sir? JVM. Three parties are involved to successful execute a Java program. Okay, now, sir, among these three, whose role is very important? Whose role is very important, sir? User is very important, or compiler is very important, or JVM is very important, sir? JVM responsibility is to execute the program. Compiler responsibility is what? To compile our program, to generate the machine code, to convert the source code file into machine code, that is byte code. Okay, and of course, user is responsible to write the Java code. Okay, sir, whose role is very important, sir? So if someone is going to ask you, sir, among Java compiler, user, and JVM, whose role is very important, sir? User role is very important, sir. User role is important, sir. Why, sir? Sir, if a user does not write .java, what the compiler will do? Compiler will only perform when the compiler will get .java file. JVM will only perform when JVM will get .class file. Okay, so user role is very important. User has the logic, user has the analyzation power, user has the imagination power. So user role is very important, sir. User is responsible to develop class. Now that class is submitted to Java compiler, and that the Java compiler will generate the .class file, and this .class file is given to JVM for execution purpose. So look at the first, sir, user. The first party is user, person who writes Java program. Okay, second party is what, sir? Java compiler. Third party is what, sir? Java virtual machine. Okay, very nice. Now, sir, life cycle of a Java program. You know already life cycle. First of all, what, sir? Test.java. Then what, sir? We submit this code to Java compiler. Then Java compiler will generate .class file, that is bytecode. This bytecode we submit to JVM, and JVM will generate the output. Correct or not? Yes, correct, sir. So first you better to take, sir, this screenshot. In order to execute a successful Java program, we need three parties. Please take this one. Please take the screenshot. Okay, fine. I hope you have taken the screenshot. Okay. Now, sir, please take the screenshot of this one as well. Okay, fine. Now, moving ahead, sir. Please take the screenshot. Life cycle of a Java program. This is the life cycle, sir. Now, sir, as I told you, the entire JVM architecture can be divided into three parts. The entire JVM architecture can be divided into three parts. What are those three parts, sir? The first one is class loader subsystem, runtime data areas, execution engine. Once again, class loader subsystem, runtime data areas, that is the memory areas. As I told you, runtime data areas is nothing but the memory areas, method area, heap area, stack area, PC register, native method stack, and the last one is what's the execution engine. So the entire JVM architecture can be divided into three parts: class loader subsystem, runtime data areas, and what, execution engine. Please take the screenshot of this one as well. Class loader subsystem, runtime data areas, execution engine. I hope you have taken the screenshot, sir. Now, let me go ahead. Now look at, sir, components in JVM architecture. Sir, here I want to show you a big diagram. Okay, a big diagram, the complete diagram. Okay, then we will discuss each and every topic in detail. Look at the complete diagram is there, sir. This is the complete diagram, sir. Just look at the complete diagram. What is the complete diagram? The dot class file. This is the dot class file. This class loader subsystem is responsible to load this dot class file. This dot class file means what, sir? The file generated by the compiler. This is what the components of JVM architecture, sir. These are the components in JVM architecture. So this dot class file, class loader subsystem is responsible to load this dot class file. Once this dot class file is loaded into JVM memory, okay, once this dot class file is loaded into JVM memory, first of all, what the JVM will do, JVM will divide the entire class data into different memories. What are, sir? Sir, thus look at the memories are method area, heap area, Java stack, PC register, native method stack. Once again, method area, heap area, Java stack, PC register, native method stack. Okay. Sir, what is the purpose of this method area? The purpose of this method area to hold the class level data. Class level data means what, sir? Sir, the dot class file is dump inside this method area, sir. The dot class file is dump inside this method area. It is holding the class level data. We will discuss in detail, don't worry. Heap object, Java stack methods, all methods are executed as a part of what, sir? Java stack. Okay, now for each thread Java creates a separate runtime stack. Listen, for each thread, for each method, actually, let's say we have a main method, again we have a thread, again we have a thread. Okay, so for each thread Java creates a separate runtime stack that is actually hold by that address execution is hold by this PC register. This PC register is hold to execute to hold to address execution instruction of each and every thread. Okay, we will talk, don't worry. Okay, we will talk here. You will get a very much clarity about Java, very much clarity about Java methods. Okay, you will get the idea what PC register is doing. Now, native method stack for what, sir? For executing the native method. Native method means what? The code you can write in C and C++, Java code you can write in C and C++. Those are called what? Native method. Now here we have an interpreter. You have an idea what is the difference between compiler and interpreter. I told you 5 to 6 points. I told you about what is the difference between compiler and interpreter. So this interpreter is what, sir? Interpreter is again responsible to execute our Java program line by line. But I hope you remember I told you that interpreter is what? Little bit slow. Interpreter is what? Slow or not? Interpreter execution is slow. Compiler execution is fast. Interpreter execution is slow. Compiler execution is fast. Interpreter debugging is fast. Compiler debugging is slow. Compiler debugging is slow, interpreter debugging is fast. Interpreter execution is slow, compiler execution is fast. So interpreter execution is slow. To boost up the execution, Java software people has provided one more compiler, that is JIT compiler, just in time compiler to boost up the performance. Next, we have what's a native method interface and then native method libraries. Okay, native method interface and native method libraries. So, in order to work with what C and C++ native languages, we have what some native method library, and this is the interface through which we can import these native method libraries. Okay, fine. So we are going to discuss this total agenda one by one. Okay, fine. Now, first of all, let me draw the diagram. Sir, what is, sir? Okay, you take the screenshot, sir. If you want, you can take the screenshot of this one. Please take the screenshot of this one. This is the components in JVM architecture. No need to draw, just take the screenshot. Okay, fine. Now, let's see. Sir, what is next, sir? The next is, look at, the next is I'm going to draw the diagram of class loader subsystem. Look at, I'm going to draw the diagram of what's a class loader subsystem. Just look at carefully, give your full attention here. Okay, class loader subsystem. Just draw your attention fully. So what is this, sir? This is actually class loader subsystem. Class loader subsystem. Okay, this is what's a class loader subsystem we have. Now, this the responsibility, of course, this class loader subsystem is what? To load the dot class file into JVM memory. Now, fine. Now, sir, when the dot class file is loaded, okay, so when class loader subsystem load the dot class file, initially at initial stage, it performs three tasks. It performs three tasks. Listen very carefully, sir, if you really want to know Java from depth. Okay, this is very important. So when the class loader subsystem is loading the dot class file into JVM, so initially it performs three tasks. What are those? Sir, first one is what? Loading. First one is what, sir? Loading. The second one is what, sir? The second one is linking. And then initialization. Sir, linking, loading, and initialization. Linking, loading, and initialization. Very nice. Now, what happens in linking, sir? What happens in linking? What happens in loading? What happens in initialization? We will learn one by one. Listen carefully. What happens at the time of loading? What happens at the time of linking? What happens at the time of initialization? Okay, so let me give you the clear picture. Okay, just wait, just listen carefully each and everything. So, in loading, sir, in loading, again we have what? In loading, again we have what? The loading responsibility is what? To load the dot class file. Listen carefully. The loading responsibility is what? To load the dot class file. Okay, dot class file. But sir, we have various kinds of dot class file or not? Yes, sir. Listen carefully what I want to say you. Let's suppose, if I am creating date d is equal to, let's say, date d is equal to new date. Date d is equal to new date. Listen carefully, sir. Date d is equal to new date. Let's say class date demo. Date demo. Okay. Now here, let's say, sir, import java dot util dot star. Okay. Now date demo. Sir, what this program will do, sir? This program will display the current system date and time or not? Yes, sir. Look at, we have already discussed, I think. Okay, so let's say date demo. So where it is, sir? It is in the anywhere you can save this program. Let's say D drive, Java, constructor demo, and let's say date demo dot Java. Okay, date demo dot Java. Let me replace date demo dot Java. Let me replace this file. Okay, sir, what is the path? D Java constructor demo date dot demo dot Java. Listen carefully. So let me compile and run this program. D Java cd constructor demo. Constructor demo Java C date demo dot Java. compile, and when you run this, you will get a current system date and time. Yes, you are what you are getting, sir? Current system date and time. Sunday, December 19th, and current system date and time. Now, if you observe this one carefully, listen, sir. Here, listen carefully, sir. Here, what the JVM will do, sir? JVM will actually load the two dot class files, sir. Listen carefully. JVM will load two dot class file. What is the first dot class file? The first dot class file generated by Java compiler. What Java compiler generated? Java compiler generated det demo dot class. Java compiler has generated det demo dot class. Correct or not? You can go in the memory or you can see. If you want, you can go to the memory, that is D drive constructor. You can see Java compiler has generated that file. So go to the Java, and here let's say constructor demo, and if you go look at sir, date demo. This is the Java file, and date demo. This is the dot class file. 19th December 8 3 a.m. This is the dot class file. This dot class file is generated by whom, sir? This dot class file is generated by Java compiler. Okay. Now class loader subsystem is responsible to load this dot class file, date demo dot class file, into JVM memory. While loading the dot class file, while loading this date demo dot class file, date demo dot class file, what class loader subsystem will do? It will also load date dot class file. It will also load date dot class file. Now look at this date demo dot class file is available in some place, means your own place, means your own directory, means your own hard disk, your own folder. But what about this date dot class file, sir? What about this data dot? It is not a user defined class, sir. It is a predefined class, already generated by, already given by Java compiler, already given by Java software people as a part of Java software. What about this date class, sir? Sir, it is not a user defined class, sir. It is a predefined class, already given by Java software people as a part of Java software. So the location of this dot class file, date dot class file, is different from the location of this date demo dot class file. That means what, sir? We need to load the class. We need to load the dot class files from different memory location. Listen once again, that means we need to load the dot class files from different memory locations. Correct or not? Yes, sir. We need to load the dot class file from different memory location. So what is the first memory location, sir? The first memory location is what? Bootstrap class loader. The first area from where we will load this class is what, sir? Bootstrap class loader. The first bootstrap class loader. Okay, bootstrap class loader, LD class loader, bootstrap class loader. Now, what is next, sir? Next is extension class loader, extension class loader, extension class loader. And what is the final, sir? Application class loader, application class loader, application class loader. Okay, these three class loader we have. These are the three class loader we have, which are used to load the required dot class file. These are the three class loader used to load the required dot class file. Listen carefully. Bootstrap class loader, extension class loader, and application class loader. Application class loader is also known as system class loader. Application class loader is also known as what's a system class loader. Now, sir, what is the role of bootstrap class loader? Okay, what is the role of bootstrap class loader? Is the role of bootstrap class loader? Sir, the bootstrap class loader is what, sir? Listen, actually, I'm just writing here, sir. Actually, when you install Java software, we have what? Java, then we have what? JDK, then we have what? GRE, then we have what? Lib library, lib, then we have what, sir? EXT. Okay, you won't find this path in JDK 17. They removed this for the security reason. But of course, if you install JDK 16, JDK 15, so this is the path: Java, JDK, GRE, lib, EXT. Okay, Java, JDK, GRE, lib, and EXT. So now listen, Java, JDK, GRE, lib, and ext. So we can have the dot class file. We can have the dot class file into what, sir? Into lib. We can have the dot class file into extension as well. Let's see. I'm showing you what I told you, sir. Listen very carefully. We can have the required dot class file into lib. We can also have a required dot class file in extension. Okay, let's see. I'm showing you here. You will get a more idea. Just look at. So this is actually we are creating class loader subsystem. This is what loading, bootstrap class loader, extension class loader, application class loader. Then we have linking, verify, prepare, and resolve, and then we have initialization. Now, if you go to the detail of this class loader, because we are focusing here, sir, class loader. If you go to the detail of this class loader, look at carefully, sir. The class loader subsystem follows delegation hierarchy algorithm. Delegation hierarchy algorithm. So this JVM is responsible. This JVM is requesting the class loader subsystem to load the dot class file. Okay, this JVM is requesting to class loader subsystem, that class loader subsystem, please load the dot class file. Please load the dot class file. Now, to load the dot class file, to load the required dot class files, we have what? Three class loader. What, sir? First one is bootstrap class loader, then extension class loader, then what? Application class loader. Bootstrap class loader, extension class loader, application class loader. First of all, listen very carefully. First of all, this class loader subsystem makes a request with application class loader. Application class loader, sir, application class loader will not perform anything. It will directly bypass the request to extension class loader. Sir, application class loader will not perform any action. It will simply bypass the request to extension class loader. Extension class loader will also not perform any action. It will simply bypass the request to bootstrap class loader. Sir, why so, sir? Why they are passing the request? Why? Because Bootstrap class loader has the highest priority. Bootstrap class loader has the highest priority among all the class loader. Among all the class loader, that is bootstrap, extension, and application, bootstrap class loader has the highest priority, as well as bootstrap class loader is the super class for extension class loader, and extension class loader is the super class for application class loader. Okay, bootstrap class loader is the super class for extension class loader, and extension class loader is the super class for application class loader. So highest priority is bootstrap class loader. Now what this bootstrap class loader will do, this bootstrap class loader, what is the responsibility of this bootstrap class loader, sir? The responsibility of this bootstrap class loader to load all the dot class file coming from Java API, coming from Java API as a part of Java software, as a part of Java software. Like right now we discuss about date class, no, sir. Date class, where it is available, sir? It is available as a part of Java software, as a part of Java software. So it will load the dot class file from that memory. So what is the part from where it will load the dot class file? JDK, GRE, lib in the library. Look, in the lib we have what? All dot class files, all dot class files given by Java software people as a part of what? Java software. In a you can see in a jar file, we have a jar file is what, sir? Jar file is a what? It's a zip file. Simple. Jar file is what? Zip file. We create a folder, zip folder now, just to compress just to compress our folder to zip folder. Similarly, in Java, we have jar folder. Jar folder means what? Compressing of dot class file folder. Compressing of, let's say we have a folder which containing number of dot class file. If we compress, what we will get? We will come. If we will compress, we will get jar file. Once again, sir, I have a folder. In that folder I have number of dot class files. Sir, I want to compress this. Yes, compress. If you come, you can, even you can compress by using Java command. So if you compress that folder which contains the dot class file, what is the result? The result is jar file, Java archive file, dot jar file. So here all the Java dot class file given by Java software as a part of Java software is present. So Bootstrap class loader is responsible to load the dot class file from Java software. Now, what about extension class loader, sir? Sir, extension class loader, listen carefully, sir. Extension class loader is responsible to load the dot class file from ext folder, sir. Look at here, up to lib. Here, what's our extension? In extension, user can put some dot class file. User can put some dot class file, sir. User, according to our requirement, I can put some jar file in the extension folder. Okay, I can put some jar file in the extension folder, my own jar file, sir. I have created my own jar file and I am putting jar file into what? Ext folder, extension folder. So extension class loader is responsible to load the dot class file from that extension folder, sir. From that extension folder. That means what? Our own dot class file created as a what? Jar file. Or from the jar file we are taking from any third party. Any third party. Let's say some other user has created jar file and I want to put that jar file as a part of our Java software package, then we can put that jar file to WhatsApp to this ext folder, inside this ext folder. Now, what about application class loader or system class loader? Sir, the use of application class loader to load the dot class file from environment variables, environment class path. Sir, directly you can give the class path from the command prompt as well by setting the what? Environment variables. So loading the dot class file from application class loader is nothing but taking the dot class file, required dot class file from environment variables. So all the area we covered, sir. All the area we covered. Okay, to load the required dot class file. But still, but still, if you are unable to load the dot class file, sir, if still you are unable to load the dot class file, then what will happen? You will get an exception. What's a Java dot lang dot class not found exception? Class not found exception. Class not found exception. Sir, when you will get this class not found exception? When the bootstrap class loader is unable to not load the dot class file, extension class loader is unable to load the dot class file, application or system class loader is unable to load the dot class file from the required memory area, then you will get an exception by JVM that, sir, even after so many try, we are unable to load your dot class file. So java.lang.class not found exception you will get. Class not found exception you will get. I hope it is clear, you guys. Okay. So remember, the dot class file is loaded from what, sir? From different memory areas. Bootstrap class loader, all predefined dot class file given by Java software people. Sir, extension class loader. Sir, third party has given some jar file. I have created my own jar file. Okay, application class loader. Sir, the dot class file from the environment variable, sir. Okay, and at all, if you are not getting the dot class file, of course, you will get the exception. What, sir? Java.lang class not found exception you will get. Okay, fine. Got it, sir. Super boss. Now, sir, what is linking? Now loading is done, sir. What is linking? Sir, linking has again a three parts, sir. What is those? Can you tell me? Yes, I am telling you. Look at the first thing is what? Look at very carefully, sir. These are the heart of Java program, sir. The first thing is what? Verify. The first thing is what? Verify. What is the second thing, sir? The second thing is what? Prepare. 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 What is the third thing, sir? The third thing is what? Resolve. Resolve. Look at very carefully, sir. Sir, verify, prepare, resolve. Okay. This is a recording session, so I will upload today itself. Okay, intentionally I have recorded. Okay, no need to worry. You just listen. You can just try to understand. This is a recording session, sir. Don't worry. So prepare, verify, prepare, and what? Resolve. Verify, prepare, and what, sir? Resolve. Sir, listen very carefully, sir. Again, you will get some heartbeat concepts. Sir, what is the use of verify? Sir, in linking, we have verify component, sir. Sir, what is the role of verify module? Sir, this verify module is responsible to check, to verify the dot class file. Listen very carefully, sir. Sir, this verify module is responsible to verify all the dot class file, and if any suspicious activity, then immediately it will stop the execution and it will generate an error, java.lang.verify error. That's why Java is highly secure language, sir. That is the reason Java is highly secure language. Okay, this verify module, actually the alternate name of this verify module is bytecode verifier. The alternate name is what, sir? Bytecode verifier. Let me write here. Bytecode verifier. Bytecode verifier. If there is a 0.001 suspicious activity, sir, 0.001 suspicious activity, I am telling you what is suspicious activity. Immediately it will stop the execution and it will throw an exception, java.lang verify error. Sir, when it will throw, sir, what is the suspicious activity, sir? Let's say the verify error will come to know that this dot class file is not coming from a proper Java compiler, or it is tempered by someone, or someone has modified something, or let's say this dot class file is generated by some different Java compiler. Yes, sir. Any suspicious activity, immediately it will stop the execution by throwing an exception, java.lang.verify error. Java.lang.what's verify error. It is a it is a linkage error, sir. It is a one kind of linkage error. Okay, yes. So we got the idea. That's why Java is highly secure, sir. That's why Java is highly secure language due to this verify. Bytecode verifier verifies all the dot class file. Okay, for any suspicious activity. Now, what about this prepare, sir? Sir, very simple. Prepare means what? Listen, prepare means what? If you have any, if you have any static data members are present in a class, listen very carefully, very simple. If you have any static data members are present in the class. Let's say in a class I have a static int x. Assume that static, not instance, static. So all these static data members are initialized with some default values. What I told you, sir, all these static data members are initialized with some default values, sir, with some default values. All these static data members of a class is initialized with some default value. Even let's say you have written, let's say you have written what, sir? You have inside the class, let's say class test. What you have written, sir? You have written a static int x is equal to 100, sir. This 100 value will come later, sir. First of all, Even you have given the value 100, doesn't matter, sir. What this prepare will do, this prepare will simply make this x value as a 0. That is a default value. That is a default value. So what is the purpose of this prepare, sir? It is allocating memory for what? For static data members. And it is what? It is just giving the default value, just putting the default values. Okay, just putting the default values for those static data member. Okay, fine, got it, sir. Now, sir, what is the resolve, sir? Sir, what is the resolve? Sir, resolve is little bit optional. It is optional. What is the resolve, sir? It converts all the direct references, all the symbolic references to direct references. What do you mean by that, sir? Let's say you are creating one class. Okay, let me draw this. Let's say, you remember, while working with what, sir? While working with a string, I told you string constant pool. Inside this string constant pool, inside this string constant pool, what happens, sir? Okay. Inside this string constant pool, one string object will be created. It is referred by what? It is referred by what? Let's say x variable. It is referred by what? Let's say x variable. X variable is referring to string constant pool. This x variable is referring to this string constant pool. Correct or not? Yes, sir. Now this is a what? Symbolic reference. This x is referring to this object. These all symbolic references will be converted to what? A direct reference. Okay, these all symbolic references will be converted to what's a direct reference. Okay, listen this point well. All symbolic references will be converted to direct reference. This is what's a resolve. Resolve. Okay, this is the purpose of resolve. All symbolic references will be converted to direct references. Resolve. Resolving. Now, what is in the initialization, sir? Sir, initialization, no need to worry. Only one part, sir. Only one part. What, sir? Initialization part done here. Only one part, sir. Initialization part. Initialization part done here. Okay, initialization part done here means what, sir? Sir, all those static data members, all those static data members which are allocated memory at prepare module and got some default values will get the actual values. So here the value of x become 100. Okay, here the value of x become 100. Now initialization. At the time of initialization, of course, the value of a static data member, that is you have given the data member value is what, sir? That you have given the data member value is what? 100. So this 100 will allocated memory here. Okay, here the x value will become 100. Okay, here the x value will become 100. And one more thing, there is a something called a static block. There is something called a static block. So this static block will be executed here. Okay, sir, this static block will be executed here. There is something called a static block. Okay, so this static block is responsible to execute in this initialization time, in the time of initialization. So, okay, I hope you got the idea of loading, linking, and what? Initialization. Loading, linking, and what? Initialization. So, loading means what? We have three kinds of class loader: bootstrap class loader, extension class loader, application class loader. Which algorithm? Delegation hierarchy algorithm follows delegation hierarchy algorithm. Delegate the request. First of all, application will delegate the request to extension. Extension will delegate the request to bootstrap, because the highest priority bootstrap class loader has the highest priority. Bootstrap class loader is the super class for extension. Extension is the super class for application. Verify, very important module, sir. Verify, very important module. What is the responsibility? The responsibility is what? To verify the byte code, to verify the dot class files. If any suspicious activity, if any problem, okay, immediately stop the execution, and it will generate an exception to the user that java.lang.verify error. Now prepare allocating the memory for a static data members with some default values. With some default values, even you have given value, doesn't matter. Here here this module will give what default values. Resolves are symbolic references will be converted to direct references. Now at initialization part, what will happen, sir? All static data member will get their actual value. And what about static block? There is something called static block which will be executed, what which will be executed at the time of initialization part done, at the time of initialization. So static block will be executed here. Okay, so I hope you have clear with this class loader subsystem. You don't have any problem. I think we will take the notes as well. Okay.